You know that feeling? You're on a video call, walking through your house or the office, and then, bam, it just freezes. You've moved from one room to another, and your Wi Fi just can't keep up. It's super frustrating, right? Well, there's actually a really clever, kind of invisible solution to this. So today, let's break down exactly how it all works.
Here's what we're going to cover. First, we'll dive into the Wi-Fi roaming problem itself. Then, we'll meet the two heroes of our story, 802.11k and 802.11v. We'll see how they work together, and finally, we'll talk about why this is such a huge deal for our super connected world.
All right, first things first, let's talk about the main issue here, something I guarantee you've run into, even if you didn't have a name for it. It's that moment, isn't it? You're literally standing right next to a Wi-Fi access point. You can see it, but your phone, for some reason, is clinging for dear life to that one bar of signal from the router 3 rooms away. So what is the deal with that? Well, this little problem has a name. It's called a sticky client. Basically, your device gets a little too attached to the first access point it connects to. It just doesn't want to let go, even when there's a much better, much stronger option right there. This is the problem we need to solve. So, how do we fix this? How do we convince our devices to not be so sticky? Well, the first part of the solution acts like a helpful scout, basically drawing a map of the area. To make this all super easy to understand, let's use an analogy. Just imagine your Wi-Fi network is this big, sprawling hotel with rooms, or, access points all over the place. Your phone or laptop is the guest, and all it wants is the best room with the best connection. Now, without 802.11, your device would have to just wander the hallways, checking every single door to see what's available. What a waste of time and battery, right? But with 802.11, it's like having a concierge at the front desk. Your device just walks up, and the concierge immediately hands it a list of all the nearby rooms. It doesn't pick one for you, it just lays out all the options. And that brings us to the techie definition. 802.11k is all about something called radio resource management. The key part here is that it lets your device ask for a neighbor report. That report is the list we've been talking about. It saves your device from having to do all that slow, battery-draining scanning on its own. Okay, having a list is great. It's a fantastic start, but it's not the whole story. What if you need more than just a list of options? What if you need some expert advice? Well, that's where our second standard comes into play. Think of 802.11v as the expert concierge. This is the one who's been working at the hotel for 20 years. They don't just know which rooms are open. They know which rooms are quiet, which ones have the best view, and which ones are right next to a noisy party. It takes that list from 802.11k and gives your device a smart, personalized recommendation. So officially, 802.11v is a wireless network management standard, and the name really says it all. The network itself can now manage the connections. It looks at things way beyond just signal strength, like how busy an access point is, and it can actively suggest a better place for your device to go. It's all about making the entire network run better. So let's put them side by side. It's actually pretty simple. 802.11k is the scout. It gives you the list of what's out there, which saves your device a ton of time. And 802.11v is the guide. It looks at that list and gives you a recommendation. It actively steers you away from bad connections, and importantly, the network itself can kickstart that conversation. Okay, we've got our scout and our guide, but let's see how this incredible team actually works together when you're on the move. So it all starts with gathering info. As you start to walk away from an access point and your signal gets weaker, your device basically asks, hey, anyone else around here? The network then generates that super helpful neighbor report we talked about. And here's what that report kind of looks like. You've got the name of the access point, the channel it's on, and its signal strength. Now, with signal strength, remember that a number closer to 0 is actually better. I know, a little weird. So at a quick glance, AP_lobby_1 at negative 55 dBm looks like the clear winner, right? But hold on. This is where the magic of 802.11v comes in. It looks at that exact same list, but it's smarter. It knows that signal strength isn't the only thing that matters. That best signal might be coming from an access point that's already struggling to handle 50 other devices. So here's the process. The network analyzes the load on all those APs. It identifies the truly optimal one. Maybe that's the one in the conference room with a slightly weaker signal, but absolutely no one on it. Then it sends a little note to your device called a BSS transition request, which is basically the network saying, hey, trust me, you'll be much happier over here.
This all sounds really neat and technical, but why did a bunch of engineers put in all this effort? Well, the answer becomes crystal clear the second you walk into a crowded place.
Seriously, just think about the last time you were at an airport or a stadium or even just a busy office. There are hundreds, maybe thousands of devices all fighting for bandwidth. Without this kind of smart management, the whole network would just collapse into a slow, unusable mess.
This teamwork is absolutely critical. It gives us intelligent load balancing, steering devices away from crowded APs so everyone gets a better experience. It cuts down on what's called airtime pollution, all that background chatter from devices screaming, "Anyone there?" This prevents a crazy traffic jam of responses from every AP in range. And what does that all add up to? A better experience for you. This is how you get a stable video call in a crowd.
So if you're going to remember just one thing from all of this, let it be this. 802.11k gives your device the what. Here are your options. And 802.11v provides the where. Here's your best move. It's a simple, elegant partnership that just makes our digital lives work. And it really makes you think, right? Our networks are getting smart enough to actively guide our devices. What other invisible decisions are being made every single second just to make sure our digital world feels totally seamless? If you had fun digging into this and making something complex feel simple, then definitely subscribe to our channel. We do explainers like this all the time. Thanks so much for watching.